Here is another question on Archimedes' principle. It's an interesting question anyway. According to this question, we have a block whose volume is 2 times 10 to the power minus 5 meter cube, and its density is 2.5 times 10 to the power 3 kilogram per meter cube. Now, this block is submerged, that means immersed in water, but with half its volume. Take note of that. Half its volume. That means it is not the whole body that is immersed now. So that is why I calculated the volume of object immersed. 1/2 times the full volume. So that means this 1 times 10 to the power minus 5 is the volume of that object that is immersed. Please take note of that. Now we have to find its apparent weight in water. Apparent weight is the same thing as weight of the object in fluid. So, and we cannot find this without knowing upthrust. How do we go about it? The first thing we have to take note of is we are given the volume of the block and the density of the block. That means we can use these two to find the mass of the block, the total mass of the block. Let's go and do that first by using the formula density is equal to mass over volume. Now, density is mass over volume. This is the density given. I'm using m0 to represent the mass of the object. Then this is the volume of the object, the total volume of the object. So by cross multiplying, mass of the object is this. So it is now this mass of the object that we will use to find the weight of the object in air by using weight is equal to mass in kilograms times acceleration due to gravity g, which is approximately 10. So the real weight of the object, which is same thing as the weight of the object or weight of the object in air, mass in kilograms times acceleration due to gravity, that will give us 0.5 Newton. So we will now use this real weight to find the apparent weight of the object in water. Don't forget, real weight is equal to apparent weight plus upthrust, or upthrust is equal to real weight minus apparent weight. Now, this is the upthrust in water, which is equal to real weight, which is 0.5 Newton, minus apparent weight, which is what we are looking for because we are asked to find its weight in water. That means we cannot find this without knowing upthrust in water. How do we now know upthrust in water? One of the formula given in my previous videos says that upthrust in a fluid is equal to density of that fluid times the volume of the object immersed times acceleration due to gravity. So I have recorded the formula. Upthrust fluid is equal to density of the fluid times volume of object immersed in the fluid times acceleration of gravity. So don't forget that the fluid we are dealing with now is water. That means upthrust in water now. Upthrust in water is equal to density of water, which is 1000, times volume of object immersed in water, which is 1 times 10 to the power minus 5, then times 10, which is a constant, acceleration of gravity. Finally, going back to this formula, since we have known the upthrust in water to be 0.1 Newton now through this formula. So upthrust in water is 0.1 equals to real weight, which is 0.5, which we have calculated before. Then minus the weight of object in water, which is the same thing as apparent weight of the object in water. By the time you rearrange, weight of object in water will be 0.5 minus 0.1, that is 0.4 Newton, which is the final answer.